Hello. So we're doing just a quick little video here to talk about the graphs that you'll be needing to make for an investigation report. Okay, so as you can see right here, I've completed my investigation. Um, this is my two data set, or my two variables in my data set. All right, I've got resistance and current. Um, and here I've got my little reminder of what you need for the instructions here. So a data table, two measured variable, any transform variables using your second graph. All right, right now I just have my measured variables. I don't need anything else. I've got, so that's done. I'll need to copy that into my report, but that's easy to do. Okay, then I'm gonna need to make a graph. So the first graph is always gonna be the same. I'm gonna take my two um, variables that I've measured, my two data sets here. I'm gonna highlight it. Okay, I'm gonna go to insert, chart, okay, and your choice here in this thing needs to be scatter chart. You can see I've got that already selected, and it should automatically do it. All right, you'll notice the first column, resistance ohms, is on the x-axis, and the second column, current amps, is on the y-axis. That's how it should be if you've done it properly, and that's hopefully how we'll run out. It auto-generated the title. Title's not that important as long as your axes are labeled properly. Okay. Um, Now we do have to add a couple things. We're going to customize here. Um, we need to have sorry. Well, one thing we have to make sure our axes are scaled, and they're scaled pretty well here. Google does a good job generally of scaling these. You can see it goes 0 to 200 spaced out. Anyways, that's fine. Um, if you want to change your chart and axes titles, you would go to customize chart and axes titles here. If you think the relationship is linear. In other words, as one of them increases or increases, the other one either linearly increases or decreases. We would need to add a trend line. Um, I think this is pretty clear that this is not a linear relationship just from looking at it, but we're going to add it anyways just to show. Okay, so we go to series. We would go to trend line. So on trend line, and then we're going to click two things. We're going to under label, we're going to use equation, and then we're going to click show r squared. Okay. Now, with that done, um, here, we've got our graph. This is the first graph you would need to make. Now, the question for you is, does this line represent the data? Okay. If it does represent the data pretty well, first of all, you'll be able to see it, right? It will go through all the points or pretty close to them. Secondly, this r squared value will be a lot higher. All right. In this case, our r squared value is not that high. The maximum r squared can be is 1, but r squared isn't great, and it doesn't look like it actually represents this data. This data looks curved to me, not linear. Okay. So the second step then, once you realize this is not linear, all right, you are going to keep this graph. It needs to be in your report, but we need to make another one. And to make another one, we need to try and figure out what this relationship actually is. Okay. So we've got a graph where as resistance increases, current gets lower. And in fact, in this case, it turns out they're inversely related. So instead of showing current versus resistance, I actually want to show 1 over current. Okay. And you can guess this and get it wrong. And that's totally fine. You just would have to try again for your second graph. But we're going to do it. So here, I'm going to make a third column. My third column is going to be 1 over current. Okay. Um, the unit for this is 1 over amps. The unit was before. Um, and the way I'm going to do that is you can use equations here. We'll do this in other cases as well, but you can type equals 1 divided by, and then if I click on this cell, it'll do it. And then actually I can autofill it down. If this doesn't show up to let you autofill it, the best way to do it is to click on this 0 and then see the little circle there. You can click on that and drag and it will do it then for you. Okay, so now this is my second one. I want to graph resistance versus current 1 amps. So I can highlight those two columns. Okay, the way I did that, right, is I actually control instead of shift. If you hold shift, or if you just drag it, it controls everything. But for control, I drag, click this, I then hold Control and drag and do this. And now I'm going to insert a chart with those two. And again, it's going to be a scatter chart. Again, I'm going to check my axes. I'm going to make sure the scaling is right. I'm going to make sure the but for both the X and Y axis. And I'm going to look at this, and hopefully you looking at this, you're like, oh, yeah, that looks pretty linear. Okay. Again, to confirm, we're going to customize. We're going to look at series. Okay. We're going to add trend line. We're going to check use equation for the label, and we're going to check show R squared. Okay. You can see here that the R squared is significantly higher, right? This time it's almost 1, which means almost perfect. It probably won't be that high. Obviously, I made up this data a little bit for our purposes, but that's what it's going to look like. Okay. All right. So both of these graphs need to be in your investigation report along with this data table. There's one final thing you need to do. You need to pay attention to the slope of this graph. Okay. The slope of this graph, that's why we add this equation. That's the primary reason. The slope of this graph is 0.657. And so the question is that number meaningful? All right. So the way we check to see if that number is meaningful is we think about what we graphed here. Okay. And I'm going to actually call up, give me 1 second here. All right. So we have our slope, which is 0.66, and we want to see if that is any meaningful relationship to our experiment. And oftentimes it will. Slopes are important generally, especially if you have a linear slope like this. So I have a graph which is 1 over I. I is the symbol for current. I know that doesn't make any sense, but that's okay. Equals, that's on the y-axis, is equal to m, which is my slope. It's too many. M times R, which is my resistance. Okay. And the actual equation that we should be representing these of current and resistance is when you have V equals I times R. So let's see if we can rearrange this equation to look like this equation. So first thing I'm going to do is I'm going to divide both sides by I. So I get V over I equals R. Okay. And then I would divide both sides by V. So I would get 1 over I equals 1 over V times R. Okay. So if then I compare this to this equation here, obviously 1 over I is the same, R is the same. This gives me that M is equal to 1 over V. Okay. Given that M is 0.66 equals 1 over V, we get that V is equal to just over 1.5. Okay. Now, why would that number be significant in this example? Well, the answer is that 1.5 volts is the voltage of the battery. So being able to see that, then we know that the slope is meaningful. It does represent something about our experiment, and that's an important thing to know. Okay. All right, so that's it for the graphs and kind of all the math and data part of an investigation that you need to do. You need to have a table. You need to have at least one graph, and you need to make another graph. If that first graph's not linear, you need to make a second graph, like this one here. Both of these need to be copied and pasted into your document. All right, and then once you have that linear graph, you need to see if this slope is meaningful and what it might represent in your experiment. And that's it. All right, thanks for watching. Hope that helped.